Good morning to one and all present here. Welcome to day 12 session of SPSS program by Dr. Dayanand Sansanwal sir, organized by SSMRV College, Bengaluru in association with Indian Teachers Education Community. I heartily welcome all our participants and I invite our respected resource person Dr. Dayanand Sansanwal sir to this program. Welcome you sir.
Thank you very much. Dear friends, I am DN Sansanwal and this is my email address. We have started with another aspect of our statistics, that the correlation one, and I have already explained you the concept of the correlation. I have told you the different statistical methods, techniques available for analyzing the data using and calculating different types of correlation. And then I had taken you to the product movement correlation or Carl Pearson product movement correlation. And this is the correlation which is mostly used in research, because here the data that you have to use is a strong data, because the scale of measurement is either interval scale or a ratio scale. So therefore, whatever now we will do henceforth, so I will be using always the product movement correlation. Okay, or its symbol is small r, not capital R. So today I am going to take you to another statistical technique. You might have heard about partial correlation. I do not know whether you understand the meaning of partial. Partialing out means taking out from the process. That is the concept of the partialing out. See, if there is a glass of water and if I find that some foreign element in that particular water, so sometimes I throw the water because of that. But suppose there is a glass of milk and in that I find there is some foreign part is there in that, then I take out that and then I drink the milk. Now when I am taking out off from the milk, it means I am partialing out. Okay, this is what, you know, in common language, that's what you do. And in day-to-day life, we will not throw the milk, or if you have pure ghee and if there is some foreign element in it, I'm sure you will not throw the ghee because it is very costly. So more costly the liquid is, you will definitely not throw it, but whatever is the foreign element in that, you will take that out and throw and then you use it. And that's what we have been doing it in our daily life. So that is the meaning of the partialing out. So the partial out means take out from the process. And in research, we have to use this technique because it is very, very, very important. Okay, so I will be taking the examples. Once again, I come to this particular aspect. So, and it's a very important concept, and large number of the researchers might be using this particular technique because it is very useful in their own research. So the presentation sequence is that I will give you the definition of the partial correlation. Then I will, as usual, I have been giving you the assumptions. And if your data violates any assumptions of the partial correlation, then you cannot analyze your data with the help of partial correlation. It's a very important thing. So you only analyze if it fulfills the assumptions. Then I have been telling you how the objective has to be worded if you want to compute correlation. Now I will tell you that if you have to analyze your data with the help of partial correlation, then what should be the wording of the objective? Dear friends, throughout my lectures, I have been emphasizing that the analysis is not in the hand of the researcher. It is directed and guided by the objective. And that is why I have been requesting that your objectives must be pinpointed. And you have been saying that when I write the objective, I try to make it as specific as not impossible. Now, so you see the wording of the objective, and if that wording is not there, then you cannot analyze your data with the help of partial correlation. So the wording is important. And then I will take you to how the hypothesis has to be formulated. And you know, if your objective wording is pinpointed, then writing hypothesis is easy. Because in hypothesis, you only have to change few words of the objective which are in the beginning, and in place of those words, you have to replace them some 4 or 5 words. And rest of the wording of the objective will become the wording of the hypothesis. So once again, you see this, and it's important. Then I will take you to the analysis part. I will take data. Okay. And before taking data, I will write objective. I will write hypothesis as I have been doing. Then I will take SPSS and some data and use SPSS. And whatever is the output I get, I try to use it to test my hypothesis and to draw the finding or come to the finding or conclusion, whatever you like to say. And then I will tell you the SPSS. This is the normal sequence which I have been using all the time. So first, let's go to partial correlation. The partial correlation is a measure of the strength. Please underline the word strength, because it will tell whether it is weak or it is strong. So measure of strength and direction. So direction, you know whether it is positive or whether it is negative. In correlation, I told you positive means both the variables will move in the same direction. Either both will move upward or both will move downward. That is the meaning of the positive. And negative means that they will move in the opposite direction. If one variable, if there are changes, upward changes in one variable, then in another variable, there will be changes in the downward direction. As I gave example, if your adjustment is poor, then your concentration will be poor. Okay, so therefore your concentration and your adjustment, they are positively related. If your concentration, if your adjustment improves, your concentration will improve. If your adjustment goes down, your concentration will also go down. But if suppose you have your the anxiety, the more the anxiety, the poorer will be your performance. So they move in the opposite direction. So you know that. So partial correlation is a measure of strength and direction of a linear relationship. Please see, it is not a curvy linear relationship. It is a linear relationship. When I was talking about the ANCOVA, analysis of covariance, and there I did tell you that the covariate must have a linear correlation with your dependent variable or the criterion variable. If the covariate does not have the linear relationship, then you cannot take that variable as a covariate. This is important. So here also, because I'm not telling you the curvy linear, because the relation may not be linear, it may be curvy linear. So important is that here the direction of a linear relationship, and when it is a linear relationship, it has to be between two variables. But what type of variables? They're continuous variables. Whenever I say the continuous variable, the meaning is that the scale of measurement is either the interval scale or the ratio scale. That's the meaning of the continuous variable once we say that. So either I can say continuous variable, or I can say that the data must be on either interval scale or on the ratio scale. So if you don't want to use that, then you can use the word continuous variable. Why? Controlling for the effect of one or more than one continuous variable. Okay, so all variables which you will consider in the case of partial correlation, they have to be continuous variable. If you have a discrete variable or a discontinuous variable, then you cannot use that variable information in computing partial correlation. For example, if you want to take gender, then you cannot use the information of gender in its calculation. Then what you have to do is, then you have to analyze separately for male and separately for female. As yesterday, I gave one example of a correlation, and there I said correlation between this and this for male and female separately. So similarly here also, if there are some discontinuous variable, then you have to do the analysis separately for each and every level of the discontinuous variable. If you want to take types of schools or types of institution, then you have to analyze it separately for private and separately for government. If you want to do for urban and rural, so it has to be done separately. Okay, so either you can say by partialing out or you can say by controlling. So in the partial correlation, the minimum number of variables must be 3. If you do not have 3 variables, if you have only 2 variables, then you only can compute correlation. But if you want to compute correlation, then you must have minimum 3 variables, and all 3 variables must be having intercorrelation, and that correlation must be as high as not impossible. So if I take, for example, the achievement, my popular variable achievement, reasoning, and steady habit. Now you know that achievement is related with reasoning. Achievement is also related with the steady habit. So if I find the correlation between reasoning and steady habit, it may comes out to be significant. Why? Because the achievement I have not taken out, it is there. So if I take out the achievement, if I control the achievement and then try to see whether the reasoning and steady habit are related or not, then you will find whether they are related or they are not related. Because I am now controlling one variable by using the partial correlation. When I was talking about the analysis of covariance, then there I did tell you the covariate that the intervening variable can be taken as a covariate here and use a statistical technique to control it. I also told you that there is another statistical technique which you can use in order to control these intervening variables. And that another technique is a partial correlation. So in partial correlation, so the minimum you must have the 3 variables, and all the 3 variables must be continuous. And then you can study the correlation between any 2 variable you like, and the third variable you have to partial it out. And when you are partialing it out, means you are keeping it constant, you are controlling it. Okay, partial out means taking out from the process, but it is not physically taking out. It is through statistical means you are just controlling that. So sometimes you can call it a control variable. Those variable which you partial out, they can be called as control. So this is what is the concept of the partial correlation. And now you can understand that partial correlation is little higher than the correlation. But the base for partial correlation is correlation, and correlation with the product movement correlation. Because it is the product movement correlation where your both the variables must be continuous variable. If one variable is continuous and another is not continuous, then you cannot use correlation, the product movement correlation. Then you have to use other correlation. So now I am closing my point by saying that in partial correlation, you have to take only those variables which are continuous variable, and those variables which you are taking, they must have relationship among themselves. That means they must have correlation among themselves. Any variable which fails to satisfy this condition, then you cannot take that variable while computing the partial correlation. Okay, so I hope I have made my point slightly clear to you. Of course, I will give other examples during the process of my presentation. Now, the assumptions of the partial correlation. One assumption is there must be at least 3 variables. Minimum number of the variable has to be 3, or it may be more, but it cannot be less than 3. 3 or more, so that correlation can be computed between the 2 variables by partialing out the effect of the third variable or other variables. Either you can use the word by partialing out, or you can use the word by controlling statistically. Okay, or by controlling the effect of that variable. So partialing out, or and whatever you like, you can use it. Another is the scale of measurement of all variables must be either interval scale or ratio scale. I have said. And another is each variable of the partial correlation should have approximately the normal distribution. If you are taking the 3 variables, so each variable must have approximately the normal distribution. And then another assumption is there must be linear relationship among the variables. Why am I using among? Because we have more than 2 variables. So these variables, they must have the linear relationship. If it is curvilinear, then you can't use it. And the another important assumption is there should not be significant outliers. These outliers, because in some of the discipline, the people, they do not talk about outliers, but normally management, etc., when these IIM, etc., when the students are taught there, they are made aware of this particular term, the outliers. And there is a mechanism to study that these are the outliers in this particular study. Okay, so the outliers, I have been telling you, those scores which are either very high or which are very low. That's what you have to do. Okay, so these are the assumptions. So your data must fulfill these assumptions, else we cannot analyze the data with the help of partial correlation. Now let us see how do we word the objective. The wording of the objective, I have been emphasizing right from the very beginning that wording of the objective cannot be done unsystematically. It is a set, wordings are there, set patterns is there. You cannot change that, because if you change, immediately the statistical technique which you want to use will change. So that is why the wording is very important. Now, one objective is to study the correlation between achievement in mathematics and reasoning of students by parceling out the effect of their study habits. Because the achievement in mathematics, the reasoning, and the study habit, all these 3 are interrelated. And therefore, I want to find out the correlation between achievement in mathematics and reasoning when I control the variable, that is the study habit I am controlling, and this I am controlling using the partial correlation technique. So it's a statistical method of control I am doing it. Okay. Now, another objective can be to study the correlation between achievement in mathematics and reasoning of students by partialing out the effect of their study habits and anxiety. In the first objective, I had the one variable which was partialed out, but in the second objective, if you say, now I have added one more variable, anxiety. So therefore, if you like, you can have as many variable as you want to control through the use of the partial correlation. So now if I analyze the data for the first objective and the second objective, the results will be very different. Because in the first one, I'm just controlling the study habit. In second one, I'm now controlling the study habit as well as anxiety. When I'm saying the first one, I'm controlling the study habit, the anxiety of student is already in the process. You have not taken it out. And now in the second case, your study habit and anxiety you have taken out. But there are many other the personality characteristics of the people which are there. Because we can't control all. It's very difficult. Let's take another objective. To study the correlation between achievement in mathematics and reasoning by partialing out the effect of study habit and anxiety of male and female students separately. So if you want to do the analysis for male and female, it has to be done separately. So you will have one result for the males and you will have another result for the females. Let's take another one. To study the correlation between research competency and reasoning, but by partialing out the effect of self-confidence, study habits, and anxiety of science, arts, and commerce teachers separately. So here I'm taking the data from the teachers. The research competency, I will have a tool, reasoning, and then I have to partial out this. And I'm taking the science teachers, arts teachers, and commerce teachers. So it has to be done separately. One analysis for science teachers, another analysis for arts teacher, and another analysis for commerce teachers. And yesterday, I demonstrated how do you filter. Okay, so you must know how to filter, because when you have the data for this objective, you will have the data of the science, arts, and commerce. So at a time you are doing only one. So others you have to partial out. So if you are doing science, the arts and commerce will partial out. If you want to do for arts, then science and commerce data will partial out. If you want to do for commerce, then science and arts data will partial out. So only those teachers who are the commerce teachers, their data will be used for the analysis. Okay, let's take another is to study the correlation between anxiety and reaction towards COVID-19 by parceling out the effect of self-confidence and adjustment of teachers. Of I have not written, so you can write, no problem. Adjustment of teachers. Okay, so these are some of the objectives. So you can still write as many as you like. Let's go to next. Now, for these, how do I formulate the hypothesis? For the first objective, the hypothesis is there is no significant correlation, because I have written to study the correlation. So I have taken out those three words, and in place of those three words, I have written four words. What are these four words? There is no significant. So just replace those three words by these four words, and rest portion of the objective will be written as it is, and that becomes a hypothesis. So the hypothesis for the first objective is there is no significant correlation between achievement in mathematics and reasoning of students by parceling out the effect of their study habits. And when I say there means the students. Next is there is no significant correlation between achievement in mathematics and reasoning of students by parceling out the effect of their study habits and anxiety. Okay, this is what the second objective was, and just replace and do this. For the third objective, the hypothesis, and all these hypotheses, I am formulating it in the null form. Okay, and these are the statistical hypothesis, because I'm using the statistical word like correlation. Okay, so in each word you see the correlation, and when I'm saying partialing out, so the technique which you use is a partial correlation. So the objective is very specific, and now the hypotheses are also pinpointed. So the third hypothesis is there is no significant correlation between achievement in mathematics and reasoning by parceling out the effect of study habits and anxiety of male and female students separately. For the fourth objective, the hypothesis is there is no significant correlation between research competency and reasoning by parceling out the effect of self-confidence, study habits, anxiety of science, arts, and commerce teachers separately. And for the last, the objective, my hypothesis is there is no significant correlation between anxiety, reaction towards COVID-19 by parceling out the effect of self-confidence and adjustment of teachers. Of course, of you can write, I forgot to write. Okay, so this is how you have to formulate your hypothesis. And now the analysis and interpretation, that I will take the data, and this data I have to enter for the partial correlation. So I know that how many minimum variables data I must enter, and whether those variables are continuous or discrete. So I know that. And then I will put the data in the proper table. After data means the results. I will put the results in the proper table and then I will interpret it. I have done the interpretation for each and every statistical technique, whatever I have demonstrated here or whatever I have taken for my lectures. And you have seen that interpretation is a very, very systematic activity. You cannot interpret the way you want to do it. No, you can't do things like this. Okay. And now let us take the data and in the SPSS and then let us use it and see how do I analyze and how do I interpret. Okay, so now I'm taking you to another one and now I'm taking you to the say SPSS, but before that I will take you to the my sheet of the Word file, and here let us take some objective. Okay, so I'm taking the objective and say my objective. So I'm say writing the objective. Now suppose if I do like this to study the correlation between. Why am I writing the word between? Because I am studying the partial correlation only between two variables. You cannot do the correlation between among three variables. No, you can't find the correlation among three variables. The correlation is always between two variables. This is important. Okay, and that is why the word is between. You can't use the word among. So to study the correlation between reasoning and achievement in mathematics, and achievement in mathematics of students by considering or by partialing out, not considering, by partialing out the effect of study habit. This, and by partialing out the effect of their study habit. If I want to just control one variable with the help of partial correlation, so therefore I write like this. So now you know that here the sample has to be of a student, but student from which class? This you will know from your title of the research. And there are three variables: reasoning, achievement in mathematics, and then the study habit. If suppose I want, let me write another one. Suppose another is to study the correlation between reasoning, achievement in mathematics by parceling out the effect of study habits of male and female students separately. Students separately. Suppose I want another one. If I say like this, to study the correlation between reasoning and achievement in mathematics by parceling out the effect of study habit of male and female students separately. And here I say by study habit of students studying in government and private schools separate. Okay? So like this, if you want, I can write as many objective like this as you want. Okay. Now, if these are my objectives, so let me copy and write the hypothesis. So I'm now writing the hypothesis, and here I'm making changes and I will make change like this. There is no significant correlation. So I will copy these 4 words and I will replace these 3 words by 4 words, and here also I replace these 3 words 4 words. So this is how I have now copied the objective and I made the changes so that it becomes the wording of the hypothesis, and I have formulated these hypotheses in the null form. Okay, now we move. So now you know that here the different variables, let me tell you the variables which I have taken here, and so you can say one variable I am taking the reasoning, another variable I am taking achievement in mathematics, another variable I am taking study habits. Why am I taking such variables? I am taking because most of you know these variables and they are not very difficult to understand, so you can appreciate their use. Now, so these are the 3 variables which I am taking, and all these 3 variables are continuous variables. The discrete variable which I am taking, one is a gender I am taking, where male and female, okay, and the another one I'm taking is government and private, so types of school I'm taking. I'm taking government and private. Okay, so that's what is important. All right. Now we go to our SPSS. Now in this SPSS, now you know where should I go first. I'm sure you have said that we go to the variable view. Now here I have to spell out all the variables, and I can do it any sequence I like. If suppose I say gender, I want to enter the information about gender. Then gender is how many levels I am taking, 2. And then I am defining is 1 means I have been saying males, 2 I have been saying females, okay, and then I say okay. Now another one is my types of school, types dot of dot schools. And now you know that here we have the 2 types of schools. One, I say the government schools. Okay. And the second, I will say private schools. And now so these are 2 my discontinuous variables. So I have written. And then now I want my other variables. And if I say reasoning, it is a discontinuous variable. So fine, I say achievement in mathematics. Achievement dot in dot mathematics. And then another is a study habit. So study dot habits. Okay, so I have spelled out all my variables in the variable view. Now I go to my data view, and now here I have to enter the data. I told you that you can take the response sheet of the first person, say what is the gender, it is female, so you put 2. If you do not remember, then you can go back to your variable view, and from there you can find out what is the code you have given for male and for female. No problem at all. Now, if the types of school, suppose he belongs to the government schools, then you say 1. What the reasoning, he has got 25. Achievement, he has got say 30. And the study habit, he has got 26. Suppose this is the, so I can enter the data of each and every person or each and every member of the sample like this, or I can enter the data of all the participants in respect of their gender, then their types of school, and then reasoning, and then this, and then this, and then this. My dear friend, I am once again telling you that all these are the data of the same person studying the gender and studying in that particular school, his reasoning, his achievement, and his study level. You cannot take somebody else reasoning and somebody else that. No, you can't do things like this. So this is important. So now I am entering the data. I will enter the gender first, and then next time I will enter types of school, and then I will enter the reasoning data, and then achievement in mathematics data, and study habitat. So I'm entering now, and you see. So I'm entering, you can keep on entering along with me, whatever you like, and I'm entering whatever I like. because I don't have the real data. Suppose I have the 76 people data I have entered. Now I'm entering the school to which they belong. So one particular child will belong to only one particular school, cannot belong to two different schools. So I'm just entering the data. I'm going from bottom to top. So you can enter the data along with me if you are having SPSS. Otherwise, you can relax till I enter my data. I could have brought the data sheet already entered, but I thought it's better you should understand it, how the data are to be entered. Okay, fine. Now we go to the next is a reasoning score. Suppose the lowest score is 10 and the highest score is 50. So then how will I enter the data? So I am now entering it. I am just entering whatever comes to my mind. So you can also enter whatever comes to your mind. Or if you have the real data, that's much better, so that you can analyze and you can see the results. So I'm just about to complete now. Okay, I have entered the data in respect of the reasoning of all the students. Now I have to enter the data of the achievement in mathematics. And suppose I want to start entering from the top and I want to come down. The maximum score, say for achievement in mathematics is say 40. So now I'm entering the scores of mathematics. The minimum score is suppose 10. So it doesn't matter. So I'll just enter and see. Maximum score is 40. All right. Now you wonder that these days in the board exam, the students, how many students are getting 100 out of 100? So many students are getting 100 out of 100. It's because the paper you can set in such a way so that everyone will get 100 out of 100. It doesn't make a much difference and it doesn't really help in improving the quality of the teaching and education. It's very difficult. There was a time when if the people used to get the distinction, they were really, you can see, yes, those people, they knew lot of things. But these days, a person has a distinction, but if you ask him few questions, he will not be able to reply, because the getting marks in the examination is very different than understanding the subject. So I request you, do not pay much attention to the marks, but pay attention to your understanding of the basic concepts. Okay. So I have entered the data related to the achievement in mathematics. Now I go to the study habits. And now my study habits, the maximum score is say 30 and minimum is say 5. So I am now entering the data of the study habit. I'm just entering whatever comes to my mind. So do not. So you may enter your data, whatever comes to your mind. Still I have to enter the data. Oh, I said 30. I'm sorry. I have put some more than 30. So I'm just changing those where I have more than 30, because I told you that we will have 30. Okay. Still there are some, so I can change, no problem. Wherever I have more than 30, I'm just quickly checking whether I have more than 30. No, now it's okay. I don't have no more than 30. So I'll just take another few seconds and I will be through my data entry and then I will proceed further. Okay, I have entered the data. All right. Now I want to do the, the first objective was to study the correlation between reasoning and achievement. Okay. So therefore, I'm just copying this because I should be ready as far as the interpretation is concerned. So this is my one. So therefore, I have to take all the students and I have to take their reasoning and the achievement. So I go to my data sheet. Now, where should I go first? I first go to analyze. Next, where? Next, I go to correlate. And when you go to correlate, you find that there are two. One is bivariate and another is partial correlation. Okay. So therefore, this is R1, 2. That means you have to find out the correlation between variable 1 and variable 2, and then it is 0.3. That means the third variable you have to partial out. Okay, it is it's a very important thing. Let me tell you first. Suppose you have the variable, say your variable 1 is say reasoning, okay, and say your variable 2 is, these are the code which you are giving. Your variable 2 is suppose study habit, and your variable 3 is suppose the achievement in mathematics. Now, if you have to say, then you have to say R, and then it is 1, 2.3. See, like this. I'm sure you are able to see this. So when I say R 1, 2.3, that means I have to find out the correlation between variable 1 and variable 2 when I'm partialing out the effect of the variable 3. But if I write like this, R 1, 3.2, the meaning is I am finding the correlation between variable 1 and variable 3 when I'm partialing out the effect of variable 2. Now, if I take one more variable, say my fourth variable is suppose, say stress. Say my fifth variable is suppose adjustment. And if suppose I write like this, R13245, the meaning is I am finding out the correlation between variable 1 and variable 3 by partialing out the effect of variable 2 and variable 4 and variable 5. I need not to put comma between 2 and 4. No, I have just to write 4, 2, 4, 5. Okay, so this is how you have to write the abbreviation for the partial correlation. And in correlation, you did not write anything like it is just between two variables. So if I write like this, if I just write like this, R13, so it means I'm finding out the correlation by using product movement correlation method, and I'm finding the correlation between variable 1 and variable 3. But the moment I say R13.2, now the statistical technique changes. And now the statistical technique is a partial correlation. It's not correlation. So therefore, this is the representation of the partial correlation. So of course, I will be using these notations afterwards. So let me now just try to delete that and go to my, say, SPSS. Okay, now here I have to go to correlate, and then I have go to partial. Say here they have not written partial correlation, they have written partial, so that's okay. So they have written bivariate. Okay, so partial correlation. Now here you go. Now you wanted to find out the correlation between reasoning and achievement in mathematics and controlling for. Now either you say controlling for or you say partialing out, both are same. Meaning is the same, words are different. So here I should bring that variable which I want to control statistically or whose effect I want to partial out. So this is how your data must be shifted in the right hand side dialog box in this particular fashion. Okay, and I'm not using gender, I'm not using types of school. Okay, because these are discontinuous variable. How to use, we will see it. Now I go to option. Do you want means and standard deviation? Yes, I can select them. Now here by default it is for two-tailed test, and whenever you formulate your hypothesis in the null form, you have to test it with the help of the two-tailed test. And the other day I told you only the difference when you say one-tailed test and two-tailed test, the formula remains the same, but the standard table values with which you will compare your calculated value to be compared with the standard table values, the table values will change. And I request all of you to take any statistics book, and towards the end of the books these tables are given. You must compare the values for the two-tailed test and the values for the one-tailed test, and you will find that the two-tailed test values will be higher than the one-tailed test. Find out the reason. Of course I will tell you the reason, no problem, but let's proceed further. So I have not to do anything. Now I can say okay. So this is my the output. Here I have the mean, here I have the standard deviation, and the total number is 76 subjects I have. All right. The correlation between reasoning and achievement in mathematics when the study habit is partial out is 0.160. And you see the significance here, it is 0.169, that means 16.9% error. Now let me just calculate the correlation between, the achievement and the reasoning, and will show you what change it will make. Now see, when the study habit is not partialed out, then the correlation between reasoning and achievement was 0.173. But when you controlled the study habit, then the correlation comes out to be 0.16. So when you have controlled, now just see the correlation between the reasoning and achievement in mathematics has been decreased. Why? Because in 0.173, the contribution of study habit is there. But in this case, you have taken it out. And when you have taken it out, then the correlation value changes. And this is what exactly is the effect of partialing out, of controlling. So when you control, their contribution is taken out, and therefore whatever comes will be a slightly better correlation. It will depict between the reasoning and achievement in mathematics. Okay, so this is the one. Now from here, how am I going to make a table, and how will I test my hypothesis? Let us see. So in this case, the correlation value is 0.16, and you know it is not significant at all. Okay. All right. So let us see how do I go to my this one. Now, what will be the heading that I want to write? Because this is my objective. The heading should be what? Can you think of? The heading will be correlation between reasoning and achievement in mathematics by parceling out the effect of study habits of students. Please do not forget to mention your population. Here, this study you have done by taking students. So population was of students. So this is the heading, the caption heading, which you have written, and you see it has been taken out from the objective. So if I change the objective, the heading will also correspondingly change. And now you have seen this, when I write the caption heading, the length should not be up to the here. No, you should cut it somewhere so that it is distinct, because your line will be a complete one, but it will be less. So now let us try to test our hypothesis. So say first objective was to study the correlation between reasoning and achievement in mathematics of students by parceling out the effect of their study habits. This is as it is, I have written. The data were analyzed with the help of partial correlation with the help of partial correlation and the results are given in table if I say 1. Now here I have to make a table, and let us make it that table, and you know you can insert the table. So we go to insert, and I say table, and I say insert, and I want to auto fit. All right. Now here what I have to do is that now I have to mention, number 1, the variables which you will be having. So the variable, okay, and here you are having the 3 variables. Okay, And then here, what will I have? I have the partial correlation. So let us write the variable first. My first variable is, say, reasoning. My second variable is, say, achievement. Achievement in mathematics. And the third is the study habit. Okay. And here I have to write R, and then here I have to write 1, 2.3. Now this R has become capital, so you have to change it once again to small. You can't write it capital. Capital R denotes multiple correlation. So you cannot write that. Okay. And now all these I don't need, so I can delete them. No problem. Okay. Now here the correlation value that comes out to 0.16. Now, so how do I write the heading of this particular table? It is partial correlation, partial correlation coefficient, partial correlation coefficient between reasoning and achievement in mathematics. Okay, by controlling study habits statistically or by parceling out the effect of study habit of students. Some of you may think, why to write such a long the table heading? Dear friends, do not bother about the long. Important is the clarity. If the student are confused with your short, the title, then it's of no use. So therefore, don't bother about the length. Important is the clarity. So therefore, and this is my not, this value is a partial correlation value. This is not correlation value. When I did the correlation, then I say correlation coefficient. Okay, so therefore here it has to be that. So this is how you write this. And now I go ahead with the interpretation. Now from table 1, it can be seen the few words here, there you can change. As I have been changing, so you can change, no problem at all. From table 1, it can be seen that partial correlation coefficient, partial correlation coefficient is 0.16, which is not significant. Here, if you do not want to use the SPSS, if you want to do analysis by hand, you can do. But to partial out more than one variable, if you do analysis with hand, it will be slightly difficult. This is number one. Now, if you want to compare this value with the value which is given in the books, so which table will you see? They do not have a table, standard table for partial correlation, but they have a standard table for correlation. So you have to see this partial correlation calculated value, you have to compare it with the table value which is given there. That's important. So you look for another table which is partial, and there is nothing like partial. As you know, that when we did analysis of variance and analysis of covariance, then the table is the same, whether you use ANCOVA or you use ANOVA. So similarly here also the table will be the same. So if you want to use that table, you can use it, no problem, but you should know the degree of freedom. And in this particular case, you know our N is 76. So my degree of freedom is 74 because -2. Okay. Now, no, I'm sorry. Here it is given, that was a correlation. Here it is given 73 because there are 76 or 3 variable. So 73. So that is here. All right. So we are not writing because it's not significant. I will make slight change and see if it comes out to be significant. Okay, then how do I go ahead with it? So from table 1, it can be seen that the partial correlation coefficient is 0.16, which is not significant. It indicates that there is, it indicates that there is no significant correlation between reasoning and achievement in mathematics of students by parceling out effect of their study habit. Parceling out their study habit. So that's the meaning. Now, once this is there, now the third sentence you write of the hypothesis, and therefore that will be, the hypothesis will be, I'm just copying from here. And I say thus, the null hypothesis that there is no significant correlation between reasoning and achievement in mathematics of student by parceling out the effect of their study habit is not rejected. Now, the moment I say is not rejected, So that means the hypothesis has been tested. And this is the third sentence which you have to write here. And now you say may it may therefore be said that reasoning and achievement in mathematics were found to be or found to have very low relationship when their study habit when the study habit and the study habits of students is partial out. Now, so this becomes your, if I take from here, reasoning and achievement in mathematics were found to have very low relationship when the study habit of students is partial out. Now, if you say this becomes your finding. So if you want, I can write here finding. And here, the first finding is this. So this is how your finding also you can. Okay. Now let us proceed further. Now see what is the second objective. Now the second objective is to study the correlation between reasoning and achievement in mathematics by parceling out the effect of study habit of male and female students. So now I have to suppose this is my another objective. So I go to my SPSS and now I have to do the analysis first for male students and then for female student, or first I do for female and then for male. It doesn't make a difference. So I go to my data and here I have to first filter out. So I said go to data and then I go to the select cases. I'm sure you know it. Yesterday I did it. And now, because at present all cases are being considered, but now we don't want to consider all cases. We want to first consider only the male data and then only the female data. So that is why I should now go to if condition is satisfied. So I go to if condition. Since I'm filtering it using gender, so I shift gender here and I want gender equal to 1. So you will have all the data of only male students, and whatever will be result, it will be for the male student. So I continue and I continue. Now, if you see the table, only the male student data you find here, and for female student, the data is already partial out. It's eliminated. Okay. So therefore, only the male data you will get. Now suppose I go to the analysis, I say analyze, I go to correlate, then I go my partial correlation. And now if suppose I have to do it, now this will be, let us say, now see, this is the data which I used for the male. There were 38 males, and here the partial correlation between reasoning and achievement in mathematics is 0.126 when the study habit is partial out. This is in case of male. Okay, so in case of male, the value is 0.126. Okay, now let us see. So go to my data and go to my data, and here I go to the split cases, and now instead of 1, now I write 2. So now I will get the data of the females. Okay, now so this is the data. Okay, I have to write, oh sorry, not this one. I have to say analyze, correlate and partial. Okay, now this is the data, and therefore now I say correlate. So this is the result which you have got in case of female, and now it is 2.208. And now you know that this value 0.208 is, you can see, a slightly higher than the 0.126, but both are not significant. Okay, so therefore both are not significant. So let us see if I have to write the interpretation. So let me now copy as I have been doing earlier. So I'll copy and then, okay. So let me copy from here. I have to copy from here. And now I am moving down. Okay. And now here I put. So this is correlation between reasoning and achievement in mathematics by parceling out the effect of study habits of, here I have to say male and female, male and female. So male and female students separately. Okay. Then I'll say the second objective was the second objective was to study the correlation between reasoning and achievement in mathematics of students, that mathematics correlation between this in mathematics by partialing out. So this I can take out by partialing out the effect of study habits. So do not forget to make changes when you copy and paste. So by partialing out the effect of study habits of male and females, male and female separately. Okay. The data were analyzed with the help of partial correlation and the results are given in table 2. So we can go to table 2. So this is the table 2. Okay, let me insert the table 2 here. Okay, now here first I say gender. Okay, because I have say and then variable. And then here is the correlation, and this correlation will be between variable 1, 2.3. And now this I have to change. So every time when you do, you have to be careful. Okay, now I want first for the male. So I'll say males. And here, now I know my 3 variables. So if you want, you can copy from here. You can copy like this. And then I can copy it here. And so I'm copying it here. All right. So my 1, 2, and the 3, they are there. Okay. Now I have to have another one for females. And now here also I have to have the same 1, 2, and this is for 3. Now the correlation value which I got partial correlation, in case of male it was 0.126. So I can say 0.126 means 1.3. In case of females, it was 0.208. So I can say 0.21. Okay. And now these are extra. So I can just delete these. And delete, of course, is not very difficult. You are expert. So it has been deleted. Okay. Now I start. Okay, objective I have written, fine. Now I have to start and writing my interpretation. So I just take it out. Now first, because I have written males, so first I have to interpret the results of the male, and then I have to interpret the results of the female. If I write the female first, then I have to interpret the results of the female first and then the male. So maintain the same sequence which you have written in your objective also. So I'll say from table 2, it is evident that partial correlation coefficient, partial correlation coefficient between reasoning and achievement in mathematics, between reasoning and achievement in mathematics of male students by parceling out the effect of their study habits. So it is evident that partial correlation between is 0.13, which is not significant. It reflects that there is no significant correlation between so let me copy paste and see what happens. It reflects that there is no significant correlation between reasoning and achievement in mathematics of male students by parceling out the effect of their study habit. Okay, and now I can write thus the null hypothesis. So I can copy this and I go ahead. Thus the null hypothesis. You have to mention null hypothesis. This is important. Thus the null hypothesis that now I am copying. Thus the null hypothesis that there is no significant correlation between reasoning and achievement in mathematics of male students by parceling out the effect of their study habits is not rejected. The moment I write this is not rejected, that means I have already tested already tested my hypothesis. Okay, now I have to write the finding. It may therefore be said that reasoning and achievement in mathematics, of students is low when their study habit, when the study habit of males, when the study habits of male students is partial out. Partial out. Partial out. Okay. So if you say reasoning and achievement in mathematics of students, if I write, I can say here male students, no problem. Male student is low when their study habit. If I write there, then I should not write. When their study habit is partial out. I can make a change like this, no problem. And here I have written male, correct. So this is how you have to write the interpretation in case of the male. Now, if you have to write interpretation in case of female, so let us say, let me now just copy. I can copy it here and then I will make the changes. The changes I am making like this. The partial correlation coefficient between reasoning and achievement in mathematics of female students by partialing out the effect of their study habit is 0.21, which is not significant. It reflects that there is no significant correlation between reasoning and achievement in mathematics of female students by partialing out the effect of their study habit, thus the null hypothesis that there is no significant correlation between reasoning and achievement in mathematics of female students by partialing out the effect of their study habit is not rejected. It may therefore be said that reasoning and achievement in mathematics of female students is low when their study habit is partial out. So therefore, now this becomes the finding. One will be for male, other will be for female. Okay. So one finding is this and another finding this. Here I write male and this is female, no problem. Because it is the same. Okay. Let us now do the analysis. Dear friends, sometimes people ask me like this, that we have analyzed our data and all our hypotheses, they are not rejected. And they say that their teacher is saying, no, this is not correct. Please understand, if you have collected the data properly and analyzed it properly, then you have not to bother whether your hypothesis, null hypothesis, is rejected or it is not rejected. you should not play with the data. And because some of the people, they have a wrong notion that at least the hypothesis should be rejected. Why should it be rejected? If your data which you have collected and you have analyzed it properly, then whatever is the result, if according to the result your null hypothesis is not rejected, then you write is not rejected. If it is rejected, then you write it is rejected. Please understand, this is very, very clear. You cannot say that all hypotheses cannot be rejected, or all hypotheses have to be rejected. No, this is a wrong notion in the mind of some of the students or some of the guides or some of the peoples. So please take care of this. All right. Now I am going to again the home. My third objective was this. This was my third objective. So let me now take this third objective, and this was my third objective. Okay. Now this third objective says you are finding the correlation between reasoning and achievement in mathematics by parceling out the effect of study habit of students studying in government and private schools. Now let me go to my data. Now this is my data. So here I have the types of school. So I go to my data, then I go to my split cases. Okay, and then I click on if condition. Now this I can delete this, and now I have to take the types of school, because gender I have is out. So I have to take types of school. So I can shift it here, and then I want, let us say, the government school. So I have written types of schools, and one means government. So I continue and I continue. So you know that your data sheet, you can see here that now it is only the school. You have to see now types of school. So all the two has been filtered out. So only the data of the government school will be taken to analyze it. Let us now do the analysis. So I am now doing the analysis, analyze. I go to compare, correlate. I go to partial, and if this is what, then I have to analyze. I'll say analyze. Okay. So this is the data which I have got for the government schools, and here the correlation is the 0.120, so it is not significant. Fine, no problem. Now let us go to data, then split cases, and now in place of 1 I should write 2. So when I'm taking 2, now this is your private, and this is your private. Now you can analyze it. Go to correlate, go to partial correlation, and now do the analysis. Now this is the result of the students studying in the private schools. So for private schools, the correlation is say 0.216, and for students studying in Government school, it was 0.120. No, I think that since I have already written the mm, the result interpretation when the results were not significant, and in case of the students belonging to government and private, it is the same story. Okay, let me try to make some changes in the this one, or let me take another data from my data sheet and then try to do the analysis. Say I'm going to my data sheet, and this of course I'm now clearing. Now I'm going to my data sheet, and here is my data sheet, and I will take some real data and will show you. Maybe that is all right. Okay. So here I am, let us see, where do I go? Let me take this data, which is Kerala data. So I'm opening the Kerala data. Now this is the data, I have got it. And here, if suppose I want to find out, say here, I can write my objective. If I find out the correlation between self-efficacy and the emotional competence, and when I am parceling out the burnout, okay, and here I have the male and female. If suppose this I want to case in case of male and female. Okay, let me first do the analysis and then I will like to do. Say so I first go to my data and then I select the cases. Now I want to select for gender. So I have to do first this if condition is satisfied, and now so I select the gender first, and gender equal to say 1. So let me see what is my result. Now you see this, my result is, no, this has not come. Let me do it again. Correlate, partial correlation. Oh, oh, sorry. Because I have only done that, I did not do this. Okay, I am finding it from the self-efficacy and emotional competence, and I am controlling the burnout. Now this will give me I only want correlation, so I don't bother. So they say, now this correlation is significant. You can see the correlation between self-efficacy and emotional competence. When the burnout is controlled statistically, then the partial correlation is 0.381. This is in case of the male students. So 0.381, and this is significant at 0.01 level. And here when the DF was 147. Okay. Now let me do it for females. So when I do for females, I have to again go to data and then select the cases. Now change this condition. So here I am saying now 2. 2 means I am taking females. So this is filtered out. This is filtered out. Okay, and now I go to analyze. go to correlation, go to partial correlation, and now this is the result. Now the result in this case is, in case of female, it is minus 0.201, and it is significant, but it is significant at 0.05 level, because here you see the significance, it is 0.014. That makes the error is 1.4%. So when the error is more than 1%, then we say it is significant at 0.05%. The 5%. Fine, we can say that. And here that your DF is also 147. Maybe number is the same. Okay. Now let us see how do I write my objectives and how do I now write my interpretation and test. So let us go. So let me go to my home page, and I am writing the another objective. I'm writing another objective. I'm just taking the second one because male and female are there, and I will change here. So it to study the correlation between self-efficacy. So I'll say self-efficacy and emotional competence. Emotional competence by partialing out the effect of burnout. So instead of study habits, I say burnout of male and female students separately. Okay. Now this is my objective. So therefore, I take this and now I write my. So I'm now just deleting this and say this is my objective. So let us see what is here. I write correlation between self-efficacy and emotional competence. By parceling out the effect of the correlation between self-efficacy and emotional intelligence by parceling out the effect of burnout of male and female students separately. Okay. This is the caption heading. So this you know. And now I can shift this on the next page. Now I say, if this is my fourth objective, then I say the fourth objective was to study the correlation between self-efficacy and emotional competence by parceling out the effect of burnout of male and female students separately. Okay. Then say the data were analyzed with the help of partial correlation and the results are given in. So I think this was my fourth table, so I say given in table 4. Now here I have to make table 4. Okay, let me insert my table. I'm inserting my table. It is auto fit content. So first is the gender. Okay. And then second, I'm taking variables. And then I'm taking the correlation. And I say 1, 2.3. It is 1, 2.3. And this I change it to R. All right. Now let me see here. I'm saying males. Okay. And here my one variable was self-efficacy. Okay. The second was emotional competence. Okay. And the third was burnout. And the same variables were in case of the females. So I say females. And then here I say, so this is my third one. Okay. Now my correlation between the self-efficacy and emotional competence when the effect of burnout was partial out, in case of male, it was 0.381. So I say 0.38. And this is significant. So I should write here remark. Okay. And here I say P is less than 0.01. So this is significant at 0.01. So this is P is okay. Now the another one, in case of female, this is minus 0.20. Okay. And here it is also significant, and here significant is 0.05 it was. So one is significant at 0.01, another is significant at 0.05. No problem. Fine, no problem. That's okay. Okay. Now I don't need the another column. So this, if you like, I can just delete. You should delete because you don't require it. Okay. Now let us see what I should write. I should write here gender-wise correlation between correlation coefficient, you can say, no problem. Correlation coefficient. When we say t value, so instead of value, it is coefficient. So this is called coefficient. So gender-wise correlation coefficient between self-efficacy and emotional competence of students by considering, or not considering, by parceling out the effect of their burnout. Okay, so this should be the heading. Now let us go ahead with the interpretation. Now from table 4, so from table 4, it can be seen that the correlation, that the partial not correlation, you should say partial correlation, okay, the partial correlation coefficient in case of males, male students is 0.38, which is significant at 0.01 level, with DF. The DF is given here, dear friends. You can see the DF is here. Right. So DF is equal to 147. It reflects that there is a positive there is a positive there is a, you can say first significant, there is a significant positive correlation between self-efficacy and emotional competence of male students male students by parceling out the effect of their burnout. Okay, now this is there, so therefore I say, thus the null hypothesis. So I'm just copying so that I can write. Thus the null hypothesis that there is no significant. Thus, the null hypothesis, there is no significant correlation between self-efficacy and emotional competence of male students is rejected. Why am I writing is rejected? Because the partial correlation coefficient is significant. Okay, now this is significant. Significant only indicates that this particular result is having very low error. It has only 1% error. It does not indicate more than that. Now, if you have to talk in terms of its strength, then you should find out the commonness. And yesterday, I told you that you can do the commonness and you can go to your calculator, and I have to find out it is 0.38. It has to be multiplied by itself. So 0.38. Now when you multiply, it is further multiplied by 100. Then this is the result you have got. So the commonness which is shared between the self-efficacy and emotional competence is only to the extent of 14.44%. It is 14.44%. Okay, let me also calculate it in case of the female. So in case of my female, the value was it was minus, so no problem. I can say minus, say 0.20, so it is 20, then multiplied by minus 0.20, and it is again multiplied by 100. Now this is now let me see, there is some problem here. I think I have made a mistake in the, okay, say it is 0.20 multiplied by 0.20, it is multiplied by 100. And if it is multiplied by 100, it is only 4% is the commonness in case of female. So let us see now, how do I write? Now here I say further the percentage of commonness between self efficacy and emotional competence okay, of male students is a male student is 14.44. I have already written percentage. Further, the percentage of commonness between self-efficacy and emotional competence of male student is 14.44 by parceling out the effect of their burnout. Okay. Now this commonness is only 14.44%, which is not very high. Okay, but it is positive. So it means now you can say it, if it would have been more than 0.5, more than 50%, the commonness would have been say 50% or around 50%, then you could have said, yes, it is substantial. But if it would have been 80 or 90%, then it is high. Okay, so you can say it may therefore be said that it may therefore be said that self-efficacy and emotional competence, that self-efficacy and emotional competence, that self-efficacy and emotional competence of male students, the self-efficacy and emotional competence are were positively related are positively related when are positively related by parceling out the effect of burnout of male students. So it may therefore be said that self-efficacy and emotional competence were found to be positively related by parceling out this. So if you take from here to here, this becomes my one of the findings. So if I take this, then this becomes my finding. So now you know it. Even if I do not do it, you can do it yourself. All right. So this is my finding which has come. Now let me see and write in case of the female, because female the correlation is negative. So let me just copy paste this, and after the interpretation I will be completing my today's talk, and then I will pass on this to the anchor, whosoever is there. Madam is there, so she will take care. Now, you see the partial correlation coefficient in case of female student is minus minus 0.20, which is significant at it is 0.05 level, and DF is the same because the number is the same. So it reflects that there is a significant, not positive, it is negative. So this is important. There is a significant negative correlation between self-efficacy and emotional competence of female students are parceling out the effect of their burnout. Thus, the null hypothesis that there is no significant correlation between self-efficacy and emotional competency of female students by parceling out the effect of their age rejected. Fine. Now, in this case, the commonness is only 4%. Further, the percentage of commonness between self-efficacy and emotional competence of female students is 4%. Okay, is so the is 4% by partialing out the effect of this. Now, this is a very, very small. This is important. And see, the correlation is a negative correlation. Negative correlation means if the self-efficacy improves, goes up, then the emotional competence comes down. And if emotional competence moves up, the self-efficacy comes down. That is only the meaning of that. Now, that this commonness is too low, okay, you can say this commonness, the percentage of commonness is too low because it is only 4%. So it may therefore be said that self-efficacy and emotional competence were found to have are found to have too low correlation, or are found to have too low correlation by partialing out the effect of burnout of female students. So this is how you can write. So I think I have given you the interpretation when your partial correlation value is significant and when your partial correlation value is not significant. Of course, here in this case, it was not too high. That is a different issue. But if you have the data, and then you may find that it is high. So therefore, this is how you can write your objectives. You can write your hypothesis, and you can analyze your data by using the SPSS, and then from the output of the SPSS, you can use whatever the relevant information you want to use it. Rest, the output information, you don't bother because you are not using. Fine. So this is how exactly it has been done. So I don't think I should take another example. I think you people have understood. If not understood, now you can ask me the questions, and when you are asking the question, I will try to reply. Now over to you, madam. Nita, madam,
Yes,
over
sir.
to you. All right.
Okay, sir. Sir, the first question is, when the correlation value comes in minus, example, minus 0.143, then what will be the answer?
Name minus, I have said minus only indicates that these two variables are inversely related. And when it is positive, then it means both the variables are positively are not inversely related. Okay, so
Okay, okay.
inversely related means if there are changes in one variable in the upward direction, so there will be corresponding changing in another variable in the downward direction. So one is inversely proportional and one is not inversely proportional. So that means it is that. So directly or indirectly proportional. So you can say minus only indicates that, and 0.14, if you square it and find out the percentage of commonness, that will give you the percentage of commonness here. Next question.
Okay, sir. Sir, what is commonness? I think it's discussed now. Is it compulsory in interpretation of correlation?
Yes, see, whenever you are talking about the correlation, if let us say correlation value is, say, suppose 0.8, it is significant and high. What does it? Commonness is 64%. 0.8 multiplied by 0.8 multiplied by 100, that is the percentage of commonness. And you know, in correlation, it is important to talk about the commonness. The more the commonness, the too strongly the variables will be related. But if the commonness is less, then the relationship between the two variables is very weak. If I take one simple example, if you pardon me, I will take example from daily life. You know, when the boy and the girl, if the parents decide that they should marry, then they take their horoscope to the Pandit. And what Pandit does? Pandit tries to compare the features, जिसको गुण कहते हैं, कि whether those features, how many are common. The higher the commonness, the better is the compatibility of the male and the female. And that is why in some of the families, whenever they try to select, they have to find out this, whether they both matches or not. So therefore, the
Okay.
commonness is a very, very important characteristic. You must, yes, when the correlation value is not significant, then you need not to talk about commonness. Perfectly correct. But when it is significant, then you must talk about the commonness because it will tell you the strength of the commonness. Next question.
Okay, sir. Sir, the last question. How to import Excel data file in SPSS?
Okay, all right. Okay. If you want Excel data, okay, fine, nice. Let me take the Excel sheet. So I'm going to my Excel sheet. I will enter the data, and then I will put it in my SPSS. No problem, because this question was there since long, so I should take it. So I'm now going to my Excel sheet. So I'm taking the Excel sheet. This is my Excel sheet here. Let us say here I put say reasoning. Okay, and suppose here I put my
Sir, your screen is not visible.
okay, it is not visible. All right.
Yes.
So that means I may have to share it, and then I think it will be all right. Hmm. Now, if I share, it is okay. Nita?
Yes, sir, it's visible now.
It's visible. All right. So if suppose I say first is say reasoning, and suppose I have another my gender. Okay, suppose I have another my say achievement. Suppose I have these data. So I am now entering the data. For reasoning, suppose I enter the data. Suppose this data I have entered. Now I am entering the gender data. So if I know one, now if I say male and female, then of course I have to change. And here also I can take another data. Fine. The achievement data I am taking. Now this is my data. Okay, now I have to change it, take it to my the SPSS. So let me see if I have to first select it. So when I'm selecting it, I can select all the variables at the same point of time. Okay, let me write one more because it is 2, and then here. Okay, so if you like, I can select 1 that for first variable, or if you like, I can select all the variables. Okay, and oh, this data is too high. All right, so I can select all the variables like this, but I must know the sequence. If I want to first select gender, then I want to select reasoning, and then I want to select achievement, that also can be done. But if I want to select in the same one, so I have done like this, then Control C. So now I can copy it. So I go this was the sheet. Okay. And now here I am pasting it. Now just see, this data has come here. So this, of course, I can delete because no problem. Now this, the data where it is VAR1, this is the data. If I do not remember, I can go to my Excel sheet. First is the reasoning. So therefore I go back, and then I go here, and here I have to say reasoning. So I can name it like this. The another data reasoning. Okay, okay, all right, okay. I have to, this is my, okay, that's fine. It's all right. That should not be there. So, but this I can change. I'm saying it is reasoning, REASONIH. The variable name, okay, because reasoning is already there. So let me write, sorry, I'm sorry, two times I made a mistake because reasoning word is already there. So I'm say REASONING. I say one. Now this is okay. Now the second variable which was there in the Excel sheet, that is gender. So gender I have already one. So I can say gender one. So this I say GENDER, gender one. Okay, this is fine. And when I say gender one, I have to write here. So I'll say one means male and two means female. Okay, and then what is my third variable in the Excel sheet? Third variable was achievement. So I just say achievement one because there is already. So this is how I can select and I can take it, import it to my SPSS, and I can make the corresponding changes in as far as the names are concerned, because when you paste it here, then you saw, because when you paste it here, then you saw the variable was uh, 0 1, and here it was 3, it was 4. So therefore I have to change. So I have changed. This is how you can shift or port the data from the Excel sheet to the SPSS sheet. I hope the person who asked me this question, he or she has understood now. Over to you, madam. Is it all right?
Yes, sir. Sir, thank you so much. It was crisp and clear like previous sessions only. Everything you have explained systematically all these days. It was really very helpful for all of us. Thank you so much
All right.
once again, sir.
Thank you very much, Nitaji. Namaskar.
Thank you, sir.
All right.
Namaskar. Thank you. So we'll end the session today. Thank you all. See you tomorrow with good hope and with good success. Thank you.